Here's a problem with grading a classifier. A model that outputs a probability doesn't hand you a decision, it hands you a score, and you need a cutoff to turn that score into a plain yes or no. Move the cutoff toward strict and you flag fewer cases. Move it toward lenient and you flag more. Where you place it completely changes how the model appears to perform, so judging it at one fixed point tells you almost nothing. The ROC curve fixes that. It sweeps the threshold across every possible setting and draws the whole picture at once, and a single number under that curve tells you how good the model really is. Let's build it up from scratch. To understand the curve, follow how it gets constructed, one step at a time. Start by moving the decision threshold. Slide it from strict, where the model only flags cases it's very sure about, all the way to lenient, where it flags almost everything. Every setting in between gives you a different classifier to score. At each threshold, compute two numbers. The true positive rate is, recall, the fraction of actual positives you manage to catch. The false positive rate is the fraction of actual negatives you wrongly flagged as positive. Together they capture the trade you're making at that setting, because catching more positives usually means raising more false alarms too. Then plot those pairs. Put the true positive rate up the vertical axis and the false positive rate along the horizontal one, and connect the dots as the threshold slides. That traced line is the ROC curve, and its shape tells the whole story. Finally, measure the area underneath. That single number is the AUC, area under the curve, and it captures the model's overall ability to separate the two classes. Beautifully, it also equals the probability the model scores a random positive higher than a random negative, so one clean number lets you compare any two models directly. So why go to all this trouble instead of reporting one score? Look at the difference. Picking one threshold gives you a single snapshot. It tells you how the model does at that exact operating point, and nothing about the others. Move the cutoff and every number shifts so a lone measurement can flatter or bury. Now, 3 ideas are worth locking in before you use it. First, remember the axes. Recall climbs the vertical, false alarms run along the horizontal, and a perfect classifier hugs the top left corner, catching every positive with 0 false alarms. A random guesser just sits on the diagonal line. Second, the AUC summarizes it all. It runs from 0.5 for random up to 1 for perfect. It doesn't depend on any single threshold, and that makes it the go-to number for comparing models at a glance. Third, watch out on imbalanced data. When positives are rare and negatives flood everything, the false positive rate stays low even while you're raising plenty of false alarms, because it's diluted by that huge negative pool. So the AUC can look deceptively rosy. That's exactly when the precision recall curve becomes the better tool to reach for. Alright, let's pull the essentials together. An ROC curve grades a classifier across every threshold at once, rather than at a single fixed operating point. It plots the true positive rate against the false positive rate, and the top left corner is where a perfect model lives. The area under the curve, the AUC, runs from 0.5 to 1 and summarizes overall separability in a single number. Just remember it can flatter a model on rare positive data. Want more machine learning ideas unpacked this cleanly? Standarity.com has a whole library of them waiting.